that the lateral surface area is twice of L plus B into H. Okay, this is the formula for lateral surface area. Please remember. And you have finally the third formula, which is the total surface area. Total surface area. What do you mean by total surface area? Suppose in your room, the total surface area is area of the four walls plus area of the ceiling plus area of the floor. That should be your total surface area. The total surface area is twice of LB plus BH plus LH. Okay, this is the formula for your total surface area. We'll require these three formulas. Now, what is the cube on the other hand? Let's see what cube is. Cube. A cube is nothing but a special type of cuboid in which all the sides are equal, all the edges are equal. This is a cube. This is a cube in which you don't have a different length, breadth, and height. All are equal to A. Length is also equal to A. Breadth is also equal to A. Okay. And the height is also equal to A. Okay. So here, what is the length? Length is equal to A. What is the breadth? Breadth is also equal to A. And what is the height? Height is also equal to A. So you can get the all the formula for a cube also if you put it in the formula for cuboid. For example, volume of a cube. Volume of a cube is L into B into H. But all are equal to A. So L is also A, B is also A, H is also A. This is A cube. Next, length of the diagonal. If you join these two vertices, what is the length of this diagonal? Length of the diagonal it is equal to root over of L square, which is A square, plus B square, which is again A square, and plus H square, which is again A square. So root over of 3A square, which can be written as root 3 into root A square, which is A into root 3. Okay, this is the length of the diagonal. You can write here units. Length of the diagonal is this much units. Next, lateral surface area or area of the four walls. Area of the four walls is equal to, in the case of cuboid, what is the formula? Twice L plus B into H. So you put L is equal to A, B is equal to A, H is also equal to A. So what do we get? Twice A plus A into A. So you get twice of 2A into A, which is 4A square. Okay, remember the formula. You don't need to derive each time. And if you are asked what is the lateral surface area of a cube, directly you must be able to say 4A square. Total surface area. Next formula is total surface area. Total surface area of a cuboid was twice L into B plus B into H plus L into H. So put A instead of all this, put AA, all this. Okay. So twice A into A plus A into A plus A into A. You get twice of A square plus A square plus A square, which is 2 into 3A square, which is 6A square. The total surface area of a cube is 6A square. Remember these formulas, and these are the only formulas that we'll require to work out the problems that follow. Let's work out some problems from the exercises. Okay. 16.4. The first problem that we are going to work out is number 10. Okay. Because most of the problems we had worked out in class 8, I'll be skipping the type that we have already done in class 8. So number 10, a closed rectangular box has inner dimensions 90 centimeter by 80 centimeter by 70 centimeter. So what are the inner dimensions? Ninety centimeter by 80 centimeter by 70 centimeter. These are the inner dimensions. Question is, calculate its capacity and the area of the tin foil needed to line its inner surface. Capacity means what? Capacity means the volume, right? So what should be the capacity? Therefore, capacity of the closed rectangular box is length into breadth into height. 90 into 80 into 70. Okay. So if you multiply all this, you'll get 504,000. This is, let's not give all this comma and all. Here's 5,04,000. What is the unit here? Centimeter. And the unit of volume is centimeter cube. So the capacity is 5,04,000 centimeter cube. The next question is, calculate the area of the tin foil needed to line its inner surface. Now, what is the inner surface? How much tin foil would be required to line its inner surface? You'll be required to line the inner surface of all the six walls, right? All the six walls, the four walls,
So total surface area.
total surface area, because you will have to line the top part, the ceiling part also, and the floor part also. Okay, so what is the total surface area um, of the area of the tin foil needed? Let's answer the second question. Area of the tin foil needed to line its inner surface is equal to total surface area of the box. And what is the total surface area? Twice L into B plus B into H plus H into L. Put the values here. Twice 90 into 80 plus 80 into 70 plus 90 into 70. Now you can calculate twice of 7200, 5600, 6300. So the total of this is 191. So it's twice of 191 and then two zeros. So this is 382. Okay. So this is the total surface of the tin foil that is needed. And what should be the unit here? We're talking about the area, so this should be centimeter square. Any question? Let us look at number 12 if you don't have any question. Now the notes on these are not available, okay, with me. I have not been able to make the notes on these, so please do your classwork from this video only. The internal measurements of a box are 10 centimeter, 8 long, 8 centimeter wide, and 7 centimeter high. So the internal measurements are 10 centimeter long, 8 centimeter wide, and 7 centimeter high. Okay, these are the internal measurements. Question is, how many cubes of size 2 centimeter can be put in the box? Now, this kind of a question actually I had discussed with you last year, if you remember. You have a box which is this much. Let me just draw it for an idea. You have this box here, and in this box, you have to accommodate some cubes. You have to keep some cubes in this box. How many cubes can you keep in this box? Okay, how many cubes of size 2 centimeter? So what you do is you line these with certain cubes here. You keep these cubes here, right? So, and what is the edge of each cube? What is the length of each edge of each cube? 2 centimeter, right? 2 centimeter. So lengthwise, how many cubes can you accommodate? Lengthwise, number of cubes that can be accommodated, that can be kept, let's say. What is the length here? 10 centimeter. So this is say 10 centimeter. Okay. And you are putting each cube of side 2 centimeter, right? So how many cubes can you keep here? 10 divided by 2? 5 cubes, right or wrong? Yes, did you understand? Anyone who did not understand this? So lengthwise you can keep 5 cubes. Let's say breadthwise. What is the breadth here? The breadth here given is 8 centimeter. So breadthwise, number of cubes that can be kept?
4.
4. Because 8 is the breadth divided by 2. 4 cubes you can keep breadthwise. Height-wise, how many cubes can you keep? Let's see what the height is first. 7 centimeter. This height is 7 centimeter. Height-wise, number of cubes
3.5.
that can be kept. Yes, height is,
3.
yes, exactly. Integer part of 7 divided by 2, because 7 divided by 2 comes out to be 3.5. So you cannot accommodate, you cannot cut a cube into half and put it there. Okay, so that means we have to neglect the 0.5 part. That means the integer part of what? 3.5. That means which is 3, right? So how many cubes are you accommodating height wise? You're only able to accommodate 3 cubes height wise. So hence, number of cubes that can be put in the box, of edge of each of edge 2 centimeter.
So 16.
Yes, all multiplication. Each of edge 2 centimeter that can be kept in the box. Lengthwise, how many you are able to keep? 5. So lengthwise you are keeping, here you are keeping 5 cubes, right? Here you are keeping how many cubes? Breadthwise, you are keeping 4 cubes. And here you are able to keep only 3 cubes, right? So how many cubes are you keeping in total? 5 into 4 into 3, which is 60.
60.
So you're only able to accommodate 60 cubes in this rectangular box or cuboidal box. Let us move on to the next question. Interesting question, in fact, the next one. It's number 14. Number 14. The question here is a cube of 11 centimeter edge is immersed completely in a rectangular vessel. So a cube is there, small cube. It is put immersed in a rectangular vessel which contains some water. Okay. If the dimensions of the base of the vessel are 15 by 12 centimeters, find the rise in the level of water in centimeters correct to 2 decimal places, assuming that no water overflows. Let's see what this question means. You have this vessel, and this vessel initially contains some water, say up to this level. Okay, up to this level, say the vessel contain water. Okay, and what are the dimensions given? The dimensions of the base of the vessel. In the question, it's written if the dimensions of the base of the vessel are 15 by 12. So that means this is my 15 and this is my 12. Dimensions of the base of the vessel are 15 by 12. And what else is given? That this cube is immersed in this. Say this cube is immersed here. Okay, it is immersed here. Okay, this cube is immersed. And what happens? Once this cube is immersed, there is a certain rise in the level of water. This water level rises to, say, this level. Okay, so the initial level was this, and the final level is this. The water level rises. The question is by what height find the rise in water level in centimeters. So let's say the height of this, let the rise in water level be h centimeter. So I assume let the rise in the level of water be h centimeters. Okay, suppose the water level rises by 8 centimeters. That is the question. You have to find h. By what height does the water level rise? A very important observation. Now, and before that, actually, what is the edge of this cube? This edge of this cube is 11 centimeters. 11 centimeters. Okay, edge of this cube that is immersed in this in this vessel is 11 centimeters. What you must observe here is that the volume of this cube, this shaded cube here that is immersed, the volume of this cube must be equal to the volume of this column of water. This is a cuboidal column, right or wrong? This water column is cuboidal or not? Yes.
Yes, sir.
The
Yes,
volume
sir.
of this cube, must be equal to this cuboidal column of water. That is what the principle on which this sum will work. So what is the volume of this cube, in fact, that is immersed? Volume of the immersed cube. Volume of the immersed cube is 11 cube, because each side is 11. Let us write this as 11 into 11 into 11 centimeter cube. This is the volume of the cube. Now, this cuboidal column of water, the length is 12 centimeters, right? In fact, the breadth is 12 centimeters, the length is 15 centimeters, and what is the height of this cuboidal column of water? 8 centimeters. So, what is the
8,
volume of water that has risen? Volume of water
12 into
risen
15
is equal to 12 into 15 into h,
into 8.
right? Centimeter cube. And you know that volume of this cube here must be equal to volume of water risen. Volume of the cube must be equal to volume of risen water. Okay, so this is volume of the cube is 11 into 11 into 11, and volume of the risen water is 12 into 15 into h. So therefore, what is h? 11 into 11 into 11 divided by 12 into 15. Let us calculate this. Nothing that cancels. So you simply need to multiply. There is nothing, nothing that you can do. 11 into 11 into 11 is 1331, and in the denominator you have 12 into 15, which is 180. Now you do your direct division, right? You know how to divide two numbers, class 3 and 4 division. You divide these two and you will get 7.39 centimeters. So this is the volume of water that has risen. Any question?
So 7.39 is height.
Yes, this is yes, this is the height. The height of water that has risen. That was the question, right? What is the height of water that has risen? You need to find it out to correct to two decimal places, and we have found out till two decimal places. Okay. Let us do the next sum. Number 15. Number 15. Going to question number 15. Till what time do you have a class? Okay. Number 15. A rectangular container whose base is a square of side 6 centimeters stands on a horizontal table and holds water up to 1 centimeter from the top. When a cube is placed in water and is completely submerged, the water rises to the top and 2 centimeter cube of water overflows. Calculate the volume of the cube. So you have this container. This is a rectangular container or a cuboidal container whose base is a square. Okay, base is a square of side 6. What do you mean by base square? This is 6 and this is also 6. So this container, the base is a square. Okay. That base is a square means this one here, this is a square. Okay. Now what happens? that this stands on a, let me just erase this. Okay. Whose base is a square of side 6 centimeters, stands on a horizontal table and holds water up to 1 centimeter from the top. Holds water up to 1 centimeter from the top. That means, say the water level is this. So this is your water level. Okay. 1 centimeter from the top. So this is your 1 centimeter from the top. This is 1 centimeter. When a cube is placed in water and is completely submerged, let us say a cube is placed here in water and is completely submerged. Okay. What happens? This water, it rises to a certain level, and now what happens? Certain water overflows also out of this. Okay. Certain water overflows. And what is this water overflowing here? This is 2 centimeter cube of water overflows. The total water that overflows is 2 centimeter cube. So water level rises also and it overflows also. The question is, calculate the volume of the cube. Now what should be the volume of the cube? Clearly, if you see, volume of the cube must be equal to volume of the displaced water, right? Displaced water means water that is rising, that is this cuboidal column of water that you have. This is the volume of water that rises, right? And how much volume of water overflows? 2 centimeter cube. So therefore, volume, this is one line problem. Volume of the cube, immersed cube, must be equal to volume of risen water plus volume of water that overflows, right? That is volume of displaced water. And how much is the volume of water that is rising? This, can you tell me this volume of this this shaded cuboid? Can you tell me what is the volume of this shaded cuboid? Can anyone tell me? Abhishek,
Yes, sir.
tell me what is the volume of this shaded cube?
1 centimeter cube.
Why 1 centimeter cube? This is your breadth, which is 6 centimeters. So 6 centimeters into, this is your length. So 6 centimeters into, and what is the height here? 1 centimeter, right?
36 centimeters.
Plus, and what is the volume of water that overflows? 2. So this is 36 plus 2. Volume of the cube is 38 centimeter cube. So this was a one line problem, actually. Okay, so we stop here for today.